So, hi everyone. So, first of all, let me know whether this audio and video are clear here. Audio and video are clear. Okay. Okay. So, hi everyone. So, first of all, let me know whether audio and video is clear so that we can start. Tell me here, is audio and video clear here? Yes or no? Okay. So, today we are going to, we'll try to solve some problems based on Coulombs law, Law. So, we try to solve some problems based on Coulombs law, Okay. Okay. Yeah. Okay. I am not able to see anything in chart here. Please let me know. Please comment in chat box here so that I will know whether it is audible or not. Is it clear here? Is it clear? Yes or no? Okay. Okay. Let's start here. So, I hope everybody knows Coulombs law here, right? Okay. So, whenever you are having two charges, let us say Q1 and Q2, separated by what? Separated by some distance, R, then the force between those charges is given by what? Is given by Coulombs law. So, we know that F is equal to what? F is equal to Q1 Q2 by 4 pi epsilon R square. Yes or no? So, everybody knows this here. Okay, I hope you know these things, right? Okay. And okay, so if they are if the two charges are of same polarity, then they are going to repel each other. If the two charges are of opposite polarity, then they are going to attract each other, right? Okay, so these things you know here, okay. So let's start this problem here. Okay. So here, what is the question they are asking here? See here, a charge Q has to be split into two fractions, Q1 and Q2. A charge Q is to be split into two fractions, Q1 and Q2, so that the force between them here, it is nothing but here it is them, okay. So the force between them is maximum. In that case, what must be the values of Q1 and Q2 if Q is equal to 10 microcoulombs? Right? Okay. Okay. Yeah. So that means what they are asking here is, you are having a charge Q here. So this charge Q is split into two fractions here. So one fraction I am considering it as Q1. So another fraction I am considering it as Q2. So a charge Q is split into two fractions, Q1 and Q2. And they are asking into two fractions. They are asking that so that the force between them is maximum. So you can split this Q amount of charge into Q1 and Q2, okay, such that the force between Q1 and Q2 must be maximum. So what must be the values of Q1 and Q2 if the total charge Q is equal to 10 microcoulombs. Okay, so that means, see here, so here you are having Q1 charge and let us say here you are having Q2 charge, right? Okay, so let us assume the distance between them is r. Let us assume the distance between them is r. Okay, so this Q1 plus Q2 here, this Q1 plus Q2 must be equal to what? Q1 plus Q2 must be equal to Q. Q1 plus Q2 must be equal to Q, right? Okay, okay, yeah. So now if Q1 plus Q2 is equal to Q, I can write Q2 as what here? I can write Q2 is equal to Q minus Q1 here. I can write Q2 is equal to Q minus Q1. Okay, so then here in place of Q1 I am having Q1 here. So in place of Q2 I am replacing with what? I am replacing with Q minus Q1. Q minus Q1. So this is nothing but Q2 value, and the distance between them is, let us say r. Let us say r. Okay, so they are asking in what ratio you have to split this charge Q into Q1 and Q2 such that the force between Q1 and Q2 must be maximum. That means the force between Q1 and Q minus Q1 must be maximum, right? Okay, so what you have to do here? So you have to vary Q1 here. You have to vary Q1. So if you vary Q1, then this Q2 is also going to vary. Then you have to determine the force between these two charges. So go on vary Q1 and hence Q2 will also going to vary. So vary both Q1 and Q2. Okay, so at what instant the force between them is going to be maximum? So when the force will be maximum, that's what you have to determine here. Okay, so if you vary Q1 here, go on vary Q1 and determine the force between these two charges. Okay, and find out when the force will be maximum. Okay, so for this what I am going to do here is, see here, so on this axis I am considering force here. So on this axis, what I have to vary here? What I am varying? I am varying Q1 here. Okay, so by varying Q1, I will try to determine the force between these two charges, and I have to find when this force will be maximum. Okay, so on this axis, what is variable here? Q1 is varying. So I am going to vary Q1 and observe what is the force. Okay, and I have to determine at what value of Q1 you are going to get maximum force. Right? Okay. Now see here. If you observe here, this charge is Q1. This is Q minus Q1. Okay. Okay. Now first initially let us take Q1 is equal to 0 here. So whenever you put Q1 is equal to 0 here, so this charge will become 0, and here you are having Q2, that is Q minus 0. So here 0 and Q will be present if you put Q1 is equal to 0. What is the force between 0 and Q here? Is nothing but what? Is nothing but 0 or not? Right? Okay. So when Q1 is equal to 0 here, if you consider Q1 is equal to 0, the force will also be equal to 0. Okay. Next, if you consider Q1 is equal to Q here, another extreme case I am considering. Consider Q1 is equal to Q. So if I consider Q1 is equal to Q here, then this charge will become 0. Yes or no? This charge will become 0. In that case also, the force is going to be 0. Okay. So here when Q1 is equal to 0, you are getting force equal to 0, and also at Q1 is equal to Q, the force is becoming 0 here. So at these two locations, at these two values of Q1, the force is becoming 0. Right? Okay. So when Q1 is equal to 0, the force is becoming 0, and when Q1 is equal to Q, the force is becoming 0. Okay, so here it is becoming 0. So as you go on increase Q1 here, okay, so the force must increase, and at some location it has to start decreasing. Again it has to reach what? 0. Right? Yes or no here? Yes or no? So at this location it is, as Q1 goes on increases, here it is becoming 0, again here it is becoming 0. So that means what? Here it is increasing, and at some location it is becoming maximum, and again decreasing, and it is going to become what? It is going to become 0 at this location, So now here at this location you are having what? You are having the force maximum, you are having the maximum force. See, actually this is very simple problem here, okay, but you have to understand the analysis here, how we have to analyze the given problem, that is important, okay. So this is the maximum force here, this is the maximum force. So at the maximum force location, at the maximum force here, at the maximum force, you have to determine what? You have to determine the value of what? The value of Q1. What must be the value of Q1 at this location, that's what you have to determine, right, okay. So now if you observe here, at this point the force is becoming maximum. So what is the slope here? What is the slope at this point? The slope is nothing but what? Slope at this location is equal to what? Is equal to 0. So whenever the force is maximum at that location, the slope is becoming equal to what? The slope is becoming 0. So here the slope is nothing but what here? The slope of this function at this location, that is df by dq. Yes or no? Df by dq1. Right, okay. So df by dq1 must be equal to what? Must be equal to 0. Right here, okay. Is it clear here? Yes or no? Okay. So df by dq1 must be equal to what? Must be equal to 0. So if you make it equal to 0, so that is nothing but the slope of this function, I am making the slope of the function is equal to 0. So if you make the slope of this function equal to 0, then you are going to get what? You can determine the charge Q1 value, okay. Yeah. So what is force here? What is force? F is nothing but what? You are having Q1 here, and here you are having Q minus Q1. So this is separated by a distance r. Now tell me, what is the force here? What is the force between them? F is equal to, so the force between 2 point charges is nothing but Q1 into Q minus Q1 divided by what? Divided by 4 pi epsilon r square. Divided by 4 pi epsilon r square. Now we have to differentiate this force with respect to what? With respect to Q1. Here Q1 is variable, yes or no? We are varying Q1 and checking when the force is becoming equal to 0. Sorry, force is becoming maximum, when the force is becoming maximum, right, okay. Yeah. So this is nothing but force. So now you have to do what here? You have to do df by dq1. You have to make df by dq1 is equal to 0. So differentiate this here, differentiate this with respect to q1. So here what you are going to get? Here it is nothing but q1 into q minus q1 square, and common is nothing but what here? 1 by 4 pi epsilon r square. I can write in this manner, right? Okay, 1 by 4 pi epsilon r square, q1 into q minus q1 square. Okay, so differentiate this function with respect to q1. So what you are going to get here? If you differentiate this term with respect to q1, you are going to get what? You are going to get q, right? Okay, next differentiate this term with respect to q1. What you are going to get? You are going to get 2 times of q1. So into 1 by 4 pi epsilon r square, 1 by 4 pi epsilon r square. This is equal to what? This is equal to 0. This is equal to 0, right? Okay. So from here what you are going to get here? If you equate this equal to 0, what you are going to get? Q is equal to 2 times of q1. Q is equal to 2 times of q1. So therefore q1 is equal to what? Q1 is equal to q by 2. Q1 is equal to q by 2, and we know that q2 is equal to what? Q2 is equal to q minus q1, that is q minus q by 2, that is equal to what? That is equal to q by 2. Okay, so that means what must be the values of q1 and q2 here? Q1 and q2 must be q by 2. So if you exactly split the total charge q exactly into 2 halves here, if you split the total charge q, exactly into 2 halves, then the force between them is going to be maximum. Right? Okay. So if you split the total charge into 2 fractions such that one is q by 2, another one is also q by 2. So in the same proportion, if you split the charge, if you split the total charge, then you are going to get what? You are going to get the maximum force between the charges. Okay, so q1 is equal to q by 2, q2 is equal to q by 2. So they have given that the total charge q is equal to what? Q is equal to 10 microcoulomb. Therefore q1 is equal to what here? q1 is equal to 10 by 2 microcoulomb, that is 5 microcoulomb. And q2 is also equal to 5 microcoulomb, right? q2 is also equal to what? Q by 2, so that is 5 microcoulomb, right? So q1 must be equal to 5 microcoulomb and q2 must be equal to 5 microcoulomb. Okay, okay. So is this clear here? Is this clear? Okay. Okay. So next problem. So next problem, see here. Okay. So next problem here, see here. So what is the problem here they are asking here? What is the problem they are asking? Two objects each of mass m, and charge q are suspended from a rigid slab through massless string of length, this is L here, okay, of length L is equal to 0.5 meters, of length L is equal to 0.5 meters. These objects repel here, this is repel, okay. So these objects repel each other and reaches an equilibrium position, at which the string makes an angle, this is theta here, this is theta, okay. String makes an angle theta equal to 45 degrees with respect to what? With respect to vertical, as shown in figure. If it is here, you must have if here, okay. So if the mass of each object is m is equal to 10 grams, here. So this is m is equal to 10 grams, right? Okay. So then determine the value of what? Determine the value of charge q. Okay. So here what is the question they are asking here? We are having two objects each of mass m. So here you are having two objects here, each of mass m and charge q, are suspended from a rigid slab, through a massless string of length L is equal to 0.5 meters. So let us consider this is rigid slab here. Okay. So from this rigid slab, you are having two strings here. Okay. To those two strings, they have attached what? They have attached two masses here, right? Okay. And those masses are having the charges q, right? Okay, you are having two masses that are hanged to the rigid slab, right? Okay, it is hanged to the rigid slab. So you are having two masses, each having the charge what? Each having the charge q, okay. So whenever you suspend the two strings here, okay, so these two balls, these two objects are having the same charge. So what they will do here? They are going to repel one another, right? So whenever you try to hang those objects through these strings, okay, since both are having the same charge q, right? Okay, so they are going to repel each other, they are going to repel each other. So whenever they are repelling each other, they will move away from one another, right? Okay, so they will move away from one another and they are going to stop at one particular location, that means at that location the net force acting on those objects will become what? Will become equal to 0. So whenever the net force is becoming equal to 0, then that position we call it as what here? Equilibrium position, right? Okay, so in that, whenever they have reached to the equilibrium position, it is given that this object is making an angle theta is equal to 45 degrees. This object is making an angle theta equal to 45 degrees with this vertical, then they are asking to determine what? Then they are asking to determine Q value. So Q is the charge that is present on both the objects here, right? So whenever you are suspending here, so since both are of same polarity, they are going to repel each other and move away from one another, and they have reached to this location, right? Okay, so at this location the net force acting on them will become what? Will become 0. Okay, has become 0. So that position we call it as what here? Equilibrium position. So whenever they have reached to that equilibrium position, it is making an angle theta equal to 45 degrees. With respect to this vertical, So in that case, what is the charge Q? That is present on this objects, So that's what they are asking here. Right? Okay. Have you understood this problem here? What they are asking? Yes or no? Have you understood this problem? Yes or no? Give some comments here so that okay, okay, and in the chat box here, we have shared a link here. Okay, we have shared a link here. So that is a Google form. We have shared one Google form. So please fill that form here. And submit. Okay. So it is shared in Google chat here. It is shared in live chat. Okay, so you just go through that and fill that Google form that is shared in live chat, right? Okay. So now see here, okay, so they have given the length. This is nothing but length here. Right? So the length of the string they have given as 0.5 meters, and mass of each object they have given as what? Mass of each object they have given as 10 grams. Okay, so 10 grams. So that is equal to 10 into 10 power minus 3 kg. And they have given theta is equal to 45 degrees. So this is the data that is available. You have to determine charge Q. Okay, see here. So now here this is in equilibrium position here. The object is in equilibrium position. So equilibrium position means what here? It is in equilibrium position. So what do you mean by equilibrium position here? Equilibrium position means the net force acting on the object. Must be equal to what? must be equal to 0. Net force acting on the object must be equal to 0. Right. Okay. So now, what are the forces? What are the forces that are acting on this object here? What are the forces that are acting on this object? Tell me here, what are the forces that are acting on this object? Tell me. See, so whenever you are having an object here, okay, so what are the forces that are going to act here? Tell me. So in downward direction, what is the force that is acting here? The force that is acting is gravitational field force. The force that is acting is gravitational field force, right? Okay. Next, what is the another force that is acting here? See, these are repelling one another. Yes or no? These two are repelling one another. Yes or no? Okay. So this charge will try to repel this. This charge will try to repel this charge in this direction because both are repelling each other. So the field force, that means the electric force will be in this direction, right? Okay. So it is going to experience the electric force in this direction because it is experiencing the repulsive force in this direction. Both are repelling one another or not? Right. Okay. So it is experiencing the electrical force in this direction and gravitational force in this direction. What is the another force here? What is the another force that is going to be present? See, whenever you are having a string here, so to this string, if you attach some object here, with this string, if you attach some object, okay, so gravitational force will try to pull this object in downward direction, but the tension in the string here, will try to pull this object in upward direction. Okay, so this is called as what here? Tension in the string, right? Okay, so the force that is present inside the string, that is nothing but what here? Tension in the string. So it is going to act in upward direction like this, right? Okay, so whenever you have suspended an object like this, okay, so this thread is pulling the object in upward direction and this gravitational pull is pulling the object in downward direction. So the force that is provided by this thread is nothing but what? Is nothing but tension force. And always remember, this tension force will be always opposite, will always point in a direction opposite to point of contact. So this is the point of contact, right? This is the point of contact between the thread and the object. So from the point of contact, it is going to point in opposite direction. That is the tension force. Right? Okay. So now here, where here? What happened here? My God. Okay. Okay, yeah. See here. Now here, this is the string. So the tension in the string, the tension force in the string is going to act in this direction. The tension force in the string is going to act in this direction. Okay, so these are the three forces here. These are the three forces that are acting on this object M, on this object having mass M and charge Q. So what are the forces? One is gravitational field force and another one is electric field force and another one is what? Tension in the string. So these are the three forces that are acting on this object and it is in equilibrium position. That means the net force acting on this object must be equal to 0. Okay, so you have to add up all these forces and equate it equal to what? Equate it equal to 0. So do that here. Let us do that. What you are going to get, tell me. So this tension here, this tension is acting in this direction. So now if I draw a vertical line, okay, so what is the angle here? What is the angle between this tension force and this line here? That is vertical. What is this angle? Here this angle, the angle between this line and this string is 45 degrees. So this is the same string and here I am drawing a parallel line to this vertical. So here theta is equal to what? Here theta is equal to 45 degrees. So if theta equal to 45 degrees, then I can resolve this tension force. Into two components. So one is along this direction and another one is what? Another one is along this direction. Right. So this component of force is nothing but what here? Is nothing but T cos theta. and this component of force is nothing but what? T sin theta. Right. Okay. So this tension force is neither horizontal nor vertical. So you can resolve this tension force into two components. One is what? One is vertical component. Another one is what? Horizontal component. Right. So this component is nothing but T cos theta, and this component is nothing but T sin theta. So now this T cos theta must be equal to what? Must be equal to this gravitational field force, because the net force that is acting on this object must be equal to what? Must be equal to 0. So that means this T cos theta is acting in upward direction, this gravitational field force is acting in downward direction. These two must be equal. And this electric force is acting in this direction, and T sin theta component, that means that the component of tension force, that is T sin theta, is acting in this direction. So these two forces must be equal, right? So then the net force on the object will become equal to what? Will become equal to 0. Okay, so equate that here, what you are going to get, tell me what you are going to get. So here T cos theta must be equal to what? Must be equal to Fg, and this T sin theta must be equal to what? Must be equal to Fe. Okay, so this is gravitational field force and this is electric field force. So now if you take T sin theta by T cos theta here, if you take T sin theta by T cos theta, if you take T sin theta by T cos theta ratio, what you are going to get? You are going to get Fe, electrical force, divided by what? Divided by Fg. Gravitational field force. Now here T will get cancelled. Now here what is Fe here? That is electrical field force between these two charges. What is the field force that is going to, that means electrical force between these two charges here? We know from Coulombs law, yes or no? So let us say the distance from between these two charges, is dr. Let us say the distance between these two charges is d. Okay. So then what is electric force you are having? Here you are having charge q, here also you are having charge q, and these two are separated by a distance d. So electric force is equal to what? Is equal to q into q, that is q square, divided by what? Divided by 4 pi epsilon naught into d square. Right. Okay. So this is the electrical force here. Now here 1 by 4 pi epsilon naught can be written as what here? Can be written as what? See, I said already epsilon naught, you can write it as what? 1 by 36 pi into 10 to the power of minus 9 farad per meter. So therefore 4 pi epsilon naught is equal to what? 4 pi into 1 by 36 pi into 10 to the power of minus 9. So 4 pi 1s, 4 pi 9s. Okay, so this is 4 pi epsilon naught value. 4 pi epsilon naught value is 9 into 10 power minus 9. So what is the value of 1 by 4 pi epsilon naught? Tell me. So 1 by 4 pi epsilon naught is equal to what? Is equal to 9. You will get, sorry, wait. It is not 9 into here, it is 1 by 9 into 10 power minus 9. So what is 1 by 4 pi epsilon naught? 1 by 4 pi epsilon naught value is equal to what? Is equal to 9 into 10 power 9. Okay, so here the electrical force, I can write it as 9 into 10 power 9 into q square divided by what? Divided by d square. So substitute that here, what you are going to get? Substitute here 9 into 10 power 9 into q square divided by what? Divided by d square. What is the gravitational field force here? What is the gravitational field force acting on this mass of m here? The mass of this object is m. So what is the gravitational field force acting on the object of mass m? That is nothing but what? Mg or not? So Fg is nothing but m into g. So this is gravitational field, acceleration due to gravity. So its value is 9.8 meter per second square. Now here you can take approximately the z value, you can take approximately 10 meter per second square. Its value. Okay, now substitute all this here. What you are going to get? You are going to get tan theta. Tan theta is equal to what? Is equal to 9 into 10 power 9 into q square divided by m is how much here? M is 10 grams. M is 10 grams. So that means I can write 10 into 10 power minus 3 kg, and z value is 10 meter per second square approximately. And what is the only one unknown here? I have to determine this d value. I have to determine this d value. So how you can determine that d value here? Tell me how you can determine this d value. How you can determine this d value? Tell me. See here, if the distance between these two charges is d, then what is the distance? What is the distance from here to here? What is the distance from here to here? The distance from here to here is nothing but d by 2. Right? Okay. So this is theta equal to 45. Here also theta must be equal to what? Theta must be equal to 45 degrees. 45 degrees. So this is d by 2, and this is nothing but what? This is nothing but length of the string. Length of the string. How much they have given here? Length of the string 0.5 meters. So they have given length of the string is 0.5 meters. Okay. So now if you observe here, so this length is 0.5 meters, right? And this distance is d by 2. So with this you can form what? You can form right angle triangle. You can form right angle triangle. So from this right angle triangle, so this will become what? This will become the opposite side. So this is angle theta. So opposite to this angle is nothing but opposite side, and this is nothing but hypotenuse. So opposite side by hypotenuse, that is sin theta. Right? Okay. So from this right angle triangle, sin theta is equal to what here? Sin theta is equal to d by 2 divided by L. D by 2 divided by L. So that is d by 2L. D by 2L. So therefore d is equal to how much here? Therefore d is equal to how much? Tell me. Therefore d is equal to 2L sin theta. D is equal to 2L sin theta. Therefore d is equal to 2 into L is 0.5 meters. Right? Okay. So sin theta is 45 degrees. So sin 45 is 1 by root 2. So you will get root 2 into 0.5, that is 1 by 2, that is you will get 1 by root 2 here. So d is equal to 1 by root 2. Finally you will get d is equal to 1 by root 2. So this is the value of d. Okay. So now substitute this d value here. Substitute this d value in this expression. Now here theta is how much? Theta is 45 degrees. So this tan 45 will become what? Will become 1. So substitute all these values here. What you are going to get here? Okay. So here you will get 1 is equal to 9 into 10 power 9 into q square divided by 10 into 10 power minus 3 into 10 into d square. D square is 1 by root 2 whole square. Okay. So from this what you have to determine? You have to determine q square value here. So what you are going to get? Q square is equal to so here 10 square, this is 10 square into 10 power minus 3. So that is 10 square into 10 power minus 3, that is 10 power minus 1 into 1 by 2 divided by 9 into 10 power 9. Right? Yes or no here? Is it correct here? Calculation? Wait here, is it correct? L is equal to 0.5 meters, 10 grams. Okay, fine. So this is m g d square. Okay, so tan theta So I think what we got, tan theta is equal to you will get 9 into 10 power 9 q square divided by, this is mg d square. Okay, wait. Okay, so q square is equal to mg d square. So here I am substituting theta equal to 45 degrees here. I am sending this term to this side. So you will get mg d square divided by 9 into 10 power 9. So q is equal to you will get square root of this one. Okay, so you can take q is equal to, so q is equal to, you will get plus or minus square root of mg d square. So you can write plus or minus d square, you can take common. Okay, d into mg is 10 grams, that is 10 into 10 power minus 3, right. G is 10 divided by 9 into 10 power 9 divided by 9 into 10 power 9, and d value we got as 1 by root 2. Okay. Okay, now here you are having 10, so take that is 10 square. If you take out of the root, what you are going to get, plus or minus 1 by root 2 into 10, and 9 you can take out of the root, that is 3. So into square root of 10 power minus 3 into 10 power minus 9. Okay, so plus or minus 1 by root 2 into 10 by 3 into, here you will get 10 power minus 12 under root, that is 10 power minus 6. Okay, you can check the calculation once here. So I think calculation somewhere mistaken. No, that's it here, right. Okay, so here 10 I can write 2 into 5, so here you will get root 2. So you will get 5 root 2 by 3 into 10 power minus 6 plus or minus. So this is the value of q here. So q is equal to, you will get plus or minus 5 root 2 by 3 microcoulomb. So both charges may be positive, or both charges may be what? Both charges may be negative here. Right. Okay. So they can be, both must be of same polarity, right, because they are repelling one another. Both must be of same polarity. So they can be either positive or they can be either negative. Okay, so 5 root 2 by 3 into 10 power minus 6. So this is the charge here. This is the charge that is present on this object here, on this object of mass m. So that is the charge that is present on this object of mass m. Okay. 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 So you can check once calculation here. If you understand procedure, that's fine here. Okay. So once you check the calculation also. I hope it is correct here. Okay. So next problem. See here. So for the following charge configurations here, for the following charge configurations, determine the point at which the net electric field becomes 0. Okay, so here I am going to give you some charge configurations here, some charge configurations. So from that charge configuration, you have to determine what? You have to determine the location or point where the net electric field, is becoming equal to what? Is becoming equal to 0, is becoming equal to 0. Okay, so first one here, first one, see here. So first one here, let us say here Q1 charge is present and here Q2 charge is present. So in the first case, consider Q1 is equal to 1 nanocoulomb and Q2 is equal to 4 nanocoulomb. And let us assume this Q1 is present at 1, 0, 0 and this Q2 is present at 4, 0, 0. So this Q1 value is how much here? 1 nanocoulomb and this Q2 value is how much? 4 nanocoulomb. So you are having this charge configuration here. You are having this charge configuration. So for this charge configuration, you have to determine what? You have to determine the point where the net electric field is becoming equal to what? Is becoming equal to 0. Right? Okay. So you have to determine the point where the net electric field is becoming equal to 0. Is becoming equal to 0. Now see here, if I consider a point here, if I consider some point, okay, so at that point let us assume some force is acting in this direction here, some force is acting in this direction, and at the same location let us assume some other force is acting in this direction, So now here the angle between these two, that is theta is not equal to what? Is not equal to 180 degrees. Theta is not equal to 180 degrees. Right? Okay. So under this situation here, you are going to have some resultant force or not? Here one force is acting in this direction, another force is acting in this direction. So you are going to have some resultant force. What is that resultant force here? How to determine? By using parallelogram law of forces. So you can draw a parallel line to F1 and you can draw a parallel line to F2. So this is going to give you what? This is going to give you the resultant force. Direction. Right. So in the same manner, if you consider somewhere here, this is F2 bar and let us say this is F1 bar. Now here also the angle between these two is not equal to what? Is not equal to 180 degrees. Under this case also you are going to have what? You are going to have some resultant force direction or not? Yes or no? You are going to have some resultant force. Right. Okay. Now if you consider at this point, okay, if both the forces are acting in the same direction here, then in this case theta is not equal to 180 degrees. Here theta equal to 0 degrees here. In this case also, what is the resultant force? Both are acting in this direction, so the resultant force will also be in the same direction. Right? Okay. So now what is the condition when this net force is going to become 0? That's what we are searching here. Okay, so let us consider this point here. At this point, the force F1 is acting in this direction, and at the same point, let us say the force F2 bar is acting exactly in opposite direction. So now here the angle between these two, that is theta is equal to what? Theta is equal to 180 degrees. Now in this case, if F1 becomes greater than F2 here, then the net force direction will be towards right. Yes. Okay, if F2 is greater than F1, then the net force is going to point in this direction. Now what is the condition for the net force to become equal to 0 here? What is the condition for the net force to become equal to 0? One is theta must be 180 degrees, and what is the next condition? That is the magnitude of F1 must be equal to what? Magnitude of F2. Yes or no? So if both the forces that are acting exactly opposite to one another, if their magnitudes are same, okay, and phase shift and the phase between them is, the angle between them is 180 degrees, then the net force at this location will become equal to what? Will become equal to 0. So this is the condition here. This is the condition for the net force to become equal to 0. right? See, if you can, whatever may be the angle here other than 180 degrees, if you are having the angle between two forces other than 180 degrees, then there is no chance for the net force to become equal to 0. So for the net force to become equal to 0, it has to satisfy two conditions. One is what here, the angle between the two forces must be equal to what? Must be equal to 180 degrees. That means they must be exactly opposite to one another. That is the first condition. And second condition is what? Second condition is the magnitude of both the forces must be what? Must be same. Must be same. Right? Okay. Jai Subesh, sir, are you from Tamil Nadu? No, yaar, actually I am from Andhra Pradesh, but right now I am staying in Tamil Nadu, yaar, in Chennai. Okay? Okay, yaar. So this is the condition here. This is the condition for the net force to become equal to 0. So first one is the phase shift. The angle must be equal to 180 degrees, and the magnitude must be same. The magnitude must be same. So these are the two conditions for the net force to become equal to 0. So you have to apply the same concept here. Yeah, you have to apply the same concept here. Right? Okay. So now see here. First of all, we will check where the angle theta will become equal to 180 degrees. Now let us consider some point here. Let us consider some point here. So at this point, the field due to Q1, the electric field due to Q1 is going to point in this direction, right? And due to this charge at this point, due to this charge, the electric field is going to point in this direction, Okay, so here the angle between these two, is not equal to 180 degrees. Let us say the field produced by Q1 is E1, the field produced by Q2 is E2. So the angle between E1 bar and E2 bar is not equal to 180 degrees. Now if you consider some point here, so here also the angle between these two field forces, is not equal to 180 degrees, So similarly, you can take any point here, okay? So the electric field is going to point like this. Here the electric field is going to point like this. Here theta is not equal to what? Theta is not equal to 180 degrees. So in this manner here, whatever the point you can take here, in this region, so whatever the point you can take okay. So in this manner, whatever the point you can take in this region, everywhere the angle is not equal to 90 degrees, and whatever the point you can take in this region, everywhere the angle condition, that is theta, is not equal to 180 degrees. Okay. So now if you consider some point here, let us assume, so this is the line here. Okay, so let us assume some point here along the line, joining the two charges. So some point here. So then due to Q1 at this point, the electric field is going to point in this direction, right? Okay, so always the field line must be away from what? Away from positive charge. So due to Q1 is positive, that is 1 nanocoulomb. So due to this Q1, the electric field is going to point in this direction, right? Okay, so this will become E1. Now due to Q2 here, now forget about this one. Due to Q2 at this point, the electric field is going to point away from what? Away from Q2, right? Okay, so the electric field is going to point in this direction, So in this manner, whatever the point you can take here, between Q1 and Q2, at each and every point, this theta will become what? Theta will become 180 degrees or not? whatever the point you can take between the two charges, whatever the point you can take between the two charges. If you consider some point here, due to Q1 the electric field is going to point in this direction, due to Q2 the electric field is going to point in this direction. So whatever the point you can take between these two charges, theta equal to 180 degrees condition will be satisfied. Now if you consider any point here, any point on this line here, you are extending this line here, okay. So if you consider any point on this line, somewhere here to the left of Q1. So now due to Q1 here, due to Q1 the electric field is going to point in this direction. This is E1 bar, and this due to Q2 the electric field is going to point what? Away from Q2. So that means it is also going to point, E2 is also going to point in this direction. Now here theta is equal to what? Theta is equal to 0 degrees. Right. Now if you consider some point here, due to Q2 the electric field is going to point in this direction, and due to Q1 the electric field is going to point in the same direction. Here also what? Here also theta is equal to what? Theta equal to 0 degrees. Right. So whatever the point you can take other than along this line here, theta will be neither 0 nor 180. Understood? Remaining in all the regions, theta is neither 0 nor 180. Only along this line, you are going to get the value of theta as either 180 or 0 degrees. If you move towards the left of Q1 here, on this line, theta will be 0. To the right of Q2, if you move along this line, theta is equal to 0. But if you consider any point between these two charges, theta is equal to 180 degrees. So that means the net electric field will become zero only between what? Only between these two charges, right? Okay, so it must be along the line between the two charges, right? Okay, so now you have to determine that point here, So Q1, Q2, okay, right. So the point must be somewhere between Q1 and Q2. So that's what we have to find out. So in this region here, only between Q1 and Q2 along this line, theta equal to 180 degrees condition will be satisfied. Yes or no? And what is the another condition here for net electric field to become equal to 0? The magnitude of E1 must be equal to what? Magnitude of E2, right? Okay, so what is the first condition? Theta must be equal to 180 degrees, okay, and second condition is the magnitude of E1 must be equal to what? Magnitude of E2. So E1 is the electric field produced by what? Produced by Q1. So what is the electric field produced by Q1 here? I can write simply Q1 by what? Q1 by 4 pi epsilon naught into R1, where R1 is the distance from Q1 here. So this must be equal to what? This must be equal to Q2 by 4 pi epsilon naught into R2, where R2 is the distance measured from Q2, okay. So here 4 pi epsilon naught will get cancelled. Q1 is equal to how much here? 1 nanocoulomb. Q2 is equal to how much? 4 nanocoulomb. So here nano will get cancelled, okay. So right, okay, see 4 pi epsilon naught R1 square here, sorry, electric field is R1 square now, Q2 by 4 pi epsilon naught R2 square, okay. So here 1 nano will get cancelled. So what you are going to get? You are going to get R2 square is equal to what? Is equal to 4 R1 square. So therefore R2 is equal to what here? R2 is equal to 2 R1. So what I said here? R2 is the distance from what? R2 is the distance measured from Q2. Where R1 is the distance from Q1, right? Okay. So now here, so from here what we can conclude? R2 is equal to 2 R1 means R2 must be what? R2 is greater than what? R2 is greater than R1. So that means the point must be present between these two charges along this line, and the distance from R2, the distance from Q2 must be greater than what here? The distance from Q1. So that point must be somewhere here, right? Okay, so the distance from Q2 to this point is R2, and the distance from Q1 to this point is R1. So this R2 must be greater than R1. That condition must be satisfied. So somewhere here the point must be present. So at this location theta is equal to what? Theta is equal to 180 degrees, right? Due to Q1 the electric field is going to point in this direction, and due to Q2 the electric field is going to point in this direction, and theta is equal to what? Theta is equal to 180 degrees. So at this location the net electric field must be equal to what? Must be equal to 0. Okay, now here you have to determine this point here. Now here, what is this total distance here? What is the total distance from here to here, here? From Q1 to Q2, tell me. From Q1 to Q2, let us say the distance is R here. From Q1 to Q2, the distance is R. So R is equal to what here? R is equal to R1 plus R2. So now tell me, what is the distance from this point to this point here? What is the distance between Q1 and Q2? Here Q1 is present at 1, 0, 0. Q2 is present at 4, 0, 0. That means the distance between Q1 and Q2 is how much here? Is how much? 3 meters. The distance between Q1 and Q2 is 3 meters. So that means R1 plus R2 here. R1 plus R2 must be equal to what? Must be equal to 3 meters. Right, and R2 is equal to what here? R2 is nothing but 2R1. So you will get R1 plus 2R1, that is 3R1 is equal to 3. So therefore R1 is equal to what? R1 is equal to 1 meter. So therefore R2 is equal to what here? R2 is equal to 2 times of R1. So you are going to get R2 is equal to 2 meters. So that point must be present. That point must be present along the line. And between the two charges at a distance of what? At a distance of R1 equal to what? R1 equal to 1 meter, and R2 must be equal to what? 2 meters. R2 must be equal to 2 meters. So what must be that point? Tell me. What is this point? Tell me. What must be this point? Tell me. So this point must be at a 1 meter distance from 1, 0, 0. So 1 meter from here to here means this point will become what here? This point will become 2, 0, 0, right? Okay, so this point will become 2, 0, 0. So then the distance from here to here is 1 meter. The distance from here to here, that is R2. R2 will become what? Here 2, 0, 0, here 4, 0, 0. That means the distance from here to here is 2 meters, right? Okay. So that means finally you got Q1 here, Q2 here. So the point must be nearer to Q1. So here the electric field is pointing like this. This is E2 bar, E1 bar, and here theta equal to 180 degrees. The distance from Q1 to this one is nothing but R1. The distance from here to here is nothing but R2. So the total distance is nothing but R, which is equal to R1 plus R2, which is equal to 3 meters. Okay. So here this point is nothing but what here? Here this point is 1, 0, 0. This point is 4, 0, 0, right? And this point, what we got here? This point is nothing but 2, 0, 0. So this is the point where the net electric field is going to become what? Is going to become equal to 0. The net electric field is going to become equal to 0. Okay. Right. Okay. Okay. Yeah. Okay. So next here. Next, if suppose in the above problem, if I have given here Q1 and here Q2. Now suppose if I have given Q1 is equal to minus 1 nanocoulomb and Q2 is equal to 4 nanocoulomb here. Q2 is equal to 4 nanocoulomb. So here this Q1 is present at 1, 0, 0 and this Q2 is present at 4, 0, 0, 4, 0, 0. Now Q1 value is minus 1 nanocoulomb and Q2 value is 4 nanocoulomb. So the distance from Q1 to Q2, that is R, is equal to what? Is equal to 3 meters. Right? Okay. So this is the data available here. Now you have to determine the point. You have to determine the point where net electric field is equal to what? Is equal to 0. Net electric field is equal to 0. Okay. So what is the condition here for the net electric field equal to 0? The magnitude of E1 must be equal to E2 and the angle theta must be equal to 180 degrees. So this angle theta equal to 180 degrees is not going to be satisfied if you take any point here or if you take any point here. It is going to be satisfied if you consider the point, only along the line joining the two charges here, only along the line joining the two charges. So this is the line here, this is the line, right? Okay, so along this line, only along this line, this condition may get satisfied. Okay, so there is a chance that that means only on this line you can get this condition here. So no other point, at no other point you are not going to get this condition, that is theta equal to 180 degrees. Whatever the point you will take, the angle between E1 bar and E2 bar is not going to be 180 degrees in this region or in this region. So it will be satisfied if you consider the point only along this line. So now you have to determine whether that point is present between these two charges or that point is present to the right of Q2 or that point is present to the left of Q1. So this is what you have to determine here. Okay, so now first let us consider some point between Q1 and Q2 here, some point between Q1 and Q2. So due to Q1, at this point the electric field is going to point in this direction. Due to Q2, the electric field is going to point in the same direction. Right? Yes or no? See, due to Q1, the electric field is going to point, always the electric field is going to point away from what? Away from positive charge. Sorry, wait. Here it is not positive charge. Wait here, sorry. Wait. Okay. So now let us consider some point here. So here Q1 is what? Q1 is minus 1 nanocoulomb, that is negative charge. So at this point, the electric field due to this minus 1 nanocoulomb will point towards what here? Always the field line will point towards what? Towards the negative charge. So the electric field is going to point towards negative charge, right? Okay, so this is due to Q1 here. Now if you consider Q2, at this point, what is the direction of electric field here? So always the electric field is going to point away from Q2. So the E2 is going to point in the same direction. So here theta is equal to what? Theta is equal to 0 degrees. So that means whatever the point you can take between this Q1 and Q2, between this Q1 and Q2, you are going to get what? You are going to get theta equal to what? Theta equal to 0 degrees. Okay, so in this region between these two charges, there is no chance for the net electric field to become equal to 0, because we are getting any point between Q1 and Q2, you are getting what? Theta equal to 0 degrees. If theta equal to 0 degrees, the net field is going to get added up. So the net field is not going to become 0 here, right? Okay. Now search for a point to the right of what? To the right of Q2. Now if you consider some point here, so due to Q2, the electric field is going to point away from Q2. So that is E2 bar is going to point in this direction. Now due to Q1, it is negative charge. So that means the electric field is going to point towards what? Towards the negative charge. So E1 is going to point in this direction. So here theta is equal to what? Theta is equal to 180 degrees. So theta equal to 180 degrees condition is satisfying to the right of what? To the right of Q2. Now if you consider any point to the left of Q1 here, to the left of Q1, let us say some point here. Okay. Now here, due to negative charge, the electric field is going to point towards what? Towards Q1, because Q1 is negative charge. So the always the electric field line will point towards what? Towards negative charge. So here this is E1 bar. Now due to Q2, the electric field at this location is going to point in this direction, that is away from Q2. So this is E2. So here the angle is theta equal to 180 degrees. So that means whether you consider any point along the line to the left of Q1 or any point along the line to the right of Q2, okay, you are getting the condition theta equal to 180 degrees. Yes or no? So that means theta equal to 180 degrees condition is satisfied either you consider a point to the right of Q2 or you consider a point to the left of Q1 along this line, Okay, so this condition is satisfied. Next, what is another condition here? The net, that means the magnitude of electric field. The magnitude of electric field must be what? Must be same. This condition must also be satisfied or not for the net electric field to become equal to 0, right? Okay, so now what is the magnitude of E1 here? What is the magnitude of E1? So that is nothing but, that is due to Q1, right? Q1 is equal to minus 1 nanocoulomb. You are considering only magnitude. So you will get 1 nanocoulomb, that is Q by 4 pi epsilon naught into what? Into R1 square, where R1 is the distance from Q1 here. So this is equal to, and the magnitude of E2, I am considering only magnitude here. So I can write Q2, that is 4 nanocoulomb divided by what? Divided by 4 pi epsilon naught R2 square. Now here 4 pi epsilon naught will get cancelled. So you are going to get R2 is equal to what? R2 is equal to, here nano will get cancelled. R2 is equal to, you will get 2 R1 here. R2 is equal to 2 R1. Now from here what you can say here, R2 is greater than what? R2 is greater than R1. So that means whatever the point that you can choose, either to the right of Q2 or to the left of Q1, okay, that point for that point R2 must be what? R2 must be greater than R1. That means the distance of that point from Q2 must be greater than the distance from Q1 here, okay. So that means what I mean is, you have to choose the point here either to the right of Q2 or to the left of Q1 such that it has to satisfy this condition. R2 must be greater than R1. So the distance from Q2 must be greater than the distance from Q1 here, the distance from Q1. Okay. So if you choose any point here, if you choose any point to the right of Q2 here, if you choose any point to the right of Q2, all these points along this line will be nearer to what? Will be nearer to Q2 when compared to what? When compared to Q1. When compared to Q1. That means here R2, the distance from Q2, R2 will be lesser than R1. Yes or no? So that point cannot be lie to the right of what? To the right of Q2. So that point must lie to the left of what? To the left of Q1 only. If you consider any point here, if you consider any point to the left of Q1, then the distance from Q1 is R1, and the distance from Q2 is nothing but what? Is nothing but R2. So now if you consider here, R2 is greater than what? R2 is greater than R1. So this condition is satisfying. That means the point must be present. The point must be present to the left of what? To the left of Q1. Okay. So at a distance of R1. From Q2 the distance is nothing but R2. Now here the distance from Q1 to Q2 is how much here? 3 meters. Is 3 meters. So that means how I can write here? The distance from here to here is R2. The distance from here to here is R. So I can write R2 minus R here. R2 minus R is equal to what? Is equal to R1. Yes or no here? So this R2 minus R will give you what? Will give you this R1. Right? Okay. So therefore I can write R2 minus R1 is equal to R, and R2 is equal to what? R2 is equal to 2R1. So 2R1 minus R1 is equal to what? Is equal to R1. So R1 is equal to, oh, wait. What I am doing here? Wait here. Okay, see this R2 here, this R2 minus R1 here. This R2 minus R1 will be equal to R here. So R2 minus R1 is equal to R, right? Okay, so R2 is equal to what? R2 is equal to 2R1. 2R1 minus R1 is equal to R1. So R1 is equal to, R value is what here? 3. So R1 value is equal to 3. So that means the distance from Q1, the distance from Q1 must be what? Must be 3 meters. 3 meters to the left, to the left. So that means what must be this point here? This point is at a distance of what? 3 meters from Q1. 3 meters from Q1 to the left here, to the left. So from this point you have to move 3 meters to the left, to the left. So that means this point will become what here? Minus 2 comma 0 comma 0, right? Yes or no? This point will become minus 2 comma 0 comma 0. Okay, so now here R2 is equal to what? R2 is equal to 2 times of R1, that is equal to what? That is equal to 6 meters. 6 meters, because R1 is equal to 3. So you will get R2 is equal to 6 meters and R1 is equal to what? R1 is equal to 3 meters. So the point must be what? The point must be minus 2 comma 0 comma 0. So the distance from here to here, R1 will be 3 meters, right? Okay, the distance from this point to this Q2, that is R2. R2 value will become what here? This is minus 2 comma 0 comma 0 and this is 4 comma 0 comma 0. So that means the distance from here to here will become what? Will become 6 meters, right? So that's what we are getting here. So exactly at this point here, that is at minus 2 comma 0 comma 0, the net electric field will become equal to what? Will become equal to 0. So therefore at minus 2 comma 0 comma 0, the net electric field will become equal to what? Will become equal to 0. Okay. Okay, is it clear here? Is it clear? Now if I consider Q1 and Q2 here, these are separated by R. So this is at 1 comma 0 comma 0 and this point is at 4 comma 0 comma 0. Let us say here Q1 is equal to 1 nano coulomb. Let us say here Q2 is equal to minus 1 nano coulomb. Q1 is equal to 1 nano coulomb and Q2 is equal to minus 1 nano coulomb. Now in this case, tell me the point at which the net electric field will become equal to 0. Tell me the point at which the net electric field is becoming equal to 0 due to this setup here. Here you are having Q1 is 1 nano coulomb and Q2 is equal to what? Q2 is equal to minus 1 nano coulomb. So due to this setup, tell me at what point you are going to get the net electric field is equal to 0. Tell me here. Tell me here. At what point the net electric field will become equal to 0? See here, it cannot be anywhere in this region and it cannot be anywhere in this region. So theta equal to 180 degrees condition will be satisfied only along this line, Okay, so here 1 nano coulomb, here minus 1 nano coulomb means if you take any charge, any point between these two charges here, due to 1 nano coulomb, the electric field is going to point in this direction. Due to minus 1 nano coulomb, the electric field is going to point in this direction. So theta is equal to 0 degrees. If you consider any point in this region, you are going to get theta equal to what? Theta equal to 180 degrees. If you consider any point in this region, you are going to get what? Theta equal to 180 degrees. So the point can be lie towards what? To the right of Q2 or it can be to the left of Q1. But what is the other condition that it has to satisfy here? First condition is theta equal to 180 degrees and second condition is what? Second condition is the magnitude of E1 must be equal to what? Magnitude of E2. So what is the magnitude of E1 here? That is 1 nano coulomb divided by 4 pi epsilon naught R1 square must be equal to what? 1 nano coulomb divided by 4 pi epsilon naught R2 square. 4 pi epsilon naught, 4 pi epsilon naught. 1 nano will be cancelled. So you are going to get R2 must be equal to what? R2 must be equal to R1. R2 must be equal to R1. So if the point lies to the right of Q2 or if the point lies to the left of Q1, will this condition will be satisfied here, R2 equal to R1? What do you mean by R2 equal to R1? The distance from Q2 and the distance from Q1 must be same. So it is not possible or not? Whatever the point you can take to the right of Q2, R2 will be lesser than R1. Okay, R2 cannot be equal to R1. Similarly, you can take any point to the left of Q1, here also you are going to get what? Here also you are going to get R1 will be lesser than R2, but you don't get this condition R2 equal to R1. So that means what here? That means there is no point in space here. There is no point in space where this net electric field will become equal to 0 due to this charge configuration. So what is this charge configuration here? Here you are having 1 nanocoulomb. Here you are having what? Minus 1 nanocoulomb. So it is just like here you are having plus Q and here you are having minus Q separated by some distance R. So you are having plus Q minus Q separated by some distance R will act as what? Will act as a dipole. Yes or no? So that means what is the conclusion I can make here? Due to a dipole you cannot find out any single point in space. Where the net electric field will become equal to 0. So due to a dipole, there exists no point in space where the net electric field will become equal to 0. Right? Okay. So this is the conclusion we can make here for this charge configuration. So these are the different charge configurations for which you have to determine what? We have determined the point where the net electric field is becoming equal to 0 here, Okay. Okay. So I hope you have understood these problems here. Okay. So now I am winding up this session here. So we are going to meet at the same time tomorrow also for EMT, and tomorrow at 10 AM we are going to have analog electronics session here. Okay. So daily at 10 AM it will be analog electronics, and at 4 PM it will be EMT here. Okay. So we will continue this session tomorrow. Okay. Okay. So thank you. Bye bye.